who want to look at this afterwards. Okay, so question number 3 was just a matter of changing something that's in logarithmic form to exponential form. So let's remember what we do. The subscript is what we call the base. It's the number that's going to end up with the exponent. The log is equal to the exponent. The log of 5, base 5, 1 over 25 equals -2, means the number on the other side of the equal sign is the exponent. And that equals the number that is right next to the word log. So in exponential form, this would have been written 5 to the -2 equals 1 over 25, which we know is a true statement because the negative exponent is telling you to take the reciprocal, and the 2 exponent means to multiply it by itself. 5 squared is 25, so therefore you get 1 over 25. So that was the answer to question number 3. Okay, now let's look at question number 2. I'm going to erase this so I have room to work. Okay. Question number 2 said, find the value of log base 4 of 1 over 64. So if I want to work that out, let's set this equal to x, because it's something I don't know what it's equal to. And now I have a log equation, so I can change it to exponential form. Again, my base is 4. My exponent is x, and that's going to give us 1 over 64. Now remember, I gave you the answer. These were the possible answers. I think you would notice right away, since it's 1 over something, the answer has to be a negative. The way you get a reciprocal, the way you get a fraction, is if your exponent is a negative. So therefore, this answer and this answer is obviously not true. So the question is, should the answer be -1/3 or -3? Well, if you think about this, 1 over 64 really means 1 over 4 to the 3rd. The exponent is 3. The 1/3 exponent would be to take the cube root. We're not taking a cube root here. We are taking an exponent of 3. The fact that it's negative comes about because this is a fraction. And the way it became a fraction was the exponent was originally a negative. So the correct answer was choice D. Did anybody get that answer? I'm looking at the chat. If you got that answer, let me know. Anybody get that correct answer? Choice D. Any questions about this? Let me see, anybody got the right answer? No. Anybody? Okay. Well, let's go on to the next example, which is really the hardest example here, this one. The question here is, sorry. The question here is to expand this expression log base 14 of the ninth root of 17 divided by s squared r into its individual logs. I just want to have something in the end that says log 17, log s, and log r. Now, if you remember what I said to do, the first thing I indicated that you must do is if you see a radical, you have to replace that radical with a exponent. And the exponent on a radical is always a fraction, and the denominator of the fraction is always what the index of the radical is. This is said the ninth root. The index is 9. So another way of writing that is to write it as 17 to the 1 over 9 exponent. That's another way of writing the nth root, the ninth root of 17. Okay. Then the next thing I told you to do is to look for anything that involves either multiplication or division. And I see I'm dividing the 17 to the 1/9 by the s squared r. So in terms of logs, we remember that the rule is that when you're dividing, you subtract the logs. And when you're multiplying, you add the logs. So this is going to be the log of 14 of 17 to the 1/9 minus the log of s squared and minus the log of r. Notice, even though the s squared and the r are being multiplied, what's more important is that they're both in the denominators. They're both, the 17 to the 1/9 is being divided by both of them. After you've done the multiplication division, you then go back and see if there's any exponents. Remember, when you're doing the exponent becomes the coefficient. So there are two places where we have exponents. The 1/9 is an exponent and the s squared is an exponent. So this becomes 1/9 log base 14 of 17 minus 2 log base, oh, I'm sorry, I didn't put in the 14s. Log base 14 of s minus log base 14 of r. And if I compare it to the choices over here, it was this one right over here. So the correct answer on this one was choice C. So those were those 3 problems that we did. As a review, again, this is what we call logarithmetic or properties of logs. We're going to look at the properties of logs and see how we can use the properties of logs to solve equations. Just before I get to that, though, let's do one other thing. As a review, we talked about solving exponential equations. And we did something like this. I'm going to do 2 different problems. First, we're going to do this problem. These are both on the practice sheet that I sent you. 5 to the 10 minus 2x equals 125. This is called an exponential equation because our variable is in the exponent. And the first way that we learned how to solve these exponential equations was to try and put both sides in terms of the same base. The base being used here is 5. Let's see if we can use base 5 on this side. Can we write 125 as 5 to some exponent? That's what I mean, write it in terms base 5. Write it as 5 to some exponent. And yes, we realize if we try it, 5 times 5 is 25, and 25 times 5 is 125. So this is really another way of writing 5 to the 3rd power. So it turns out that we have the 5 to the 10 minus 2x equaling to the 5 to the 3rd power. Since they're both to base 5, we can then say if their bases are the same, their exponents, which on this side is 10 minus 2x, has to be as the same exponent as the one on the other side. It has to be equal to 3. So now it's just a matter of solving this equation. I'll subtract 10 from both sides, which will give me negative 2x equals 3 minus 10, which is negative 7. And I'll divide by negative 2. And I'll get negative over negative, which is positive, and my answer is 7 over 2. And you could leave it as a fraction like this. You do not have to change it to a decimal. Your answer would be 7/2. Here's one for you to try. 2 to the x plus 4 equals 32. While you're doing that one, I'm going to take attendance. Ray Adams. Can you hear me? Ray Adams. Lukey.
Here. Good morning.
Good morning. Farhas.
Good morning.
Good morning. Justin. Justin Brewster. Jordan Calendar. Jordan. Halima Kamara.
Good morning, Professor.
Good morning. Kaimani Clark. Kaimani. Shanice Craddock.
I'm here.
Good. Carmelita Cross.
I'm here. Good morning.
Good morning. Monette Daniels. I think Monette was here. Okay, I don't see her on my list. Darren Dasney.
Here.
Good. Cheyenne Duncan. Cheyenne. Tiamani Farron.
Excuse me, Professor. Kimani.
Okay, is that Tiamani that just answered?
No, Kimani Clark. Yeah.
I was helping for Mari right now.
Okay. Stephanie Fuentes.
Excuse me,
Stephanie-
Professor.
Okay, good. Tyler Graham.
I'm here.
Good. Deshaun Gutierrez. Ariel Harvey. Hoda Hassan.
I'm here.
Hoda, you're here, good. Caesar Hicks. Zanaya Jenkins.
Here.
Good. David Johnson.
Here.
Good. Okay, Manny. Okay, I'll see you. I see you. Yoel Johnson.
Here.
Good. Diamond George. Snapbar Laborde. Jefferson Lane. Kai Lee. Teresa Lindsay.
Good
Teresa,
morning, I'm here.
good morning. Partana Nath. Okay, good. I'm good. I see you, Partana. Sosa Odemwingie. Sosa. Jennifer Pasio.
I'm here.
Good. Amy Sandoval.
Present, I'm here.
Okay, good. Evelyn Sola.
Hi, I'm here.
Good. Cheyenne Short.
Good morning, I'm here.
Okay. Aisha Silla. Aisha. Daryl Stewart. Daryl Stewart. Camille White. Martin Williams.
I'm here.
Good. Nikisha Williams.
I'm here.
Good. And Marcus Williamson.
I'm here.
Good. Okay, so. And you got the answer to be equal to 1. Let's see if 1 is the correct answer. Just like we did before, we're going to try and put these both into terms of the same base. The base being used here is 2. So I try and figure out what would 2 be in base, what would 32 be if we were put it in with 2 to some exponent. So let's see. 32 is 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. In other words, I had to multiply 2 5 times in order to get 32. So it turns out that the 32 could be really written as 2 to the 5th power. Now, that means the x plus 4 must equal 5, because this is really 2 to the 5th. The exponents are the same now. And bringing the 4 to the other side just gives me x equal to 1, positive 1, which is, I think, the answer that Evelyn had given. So notice we were able in both of these cases to solve these exponential equations by putting them both in terms of the same base. So let's look at another question. Let's say I gave you this question. 5 to the 2x equals 64. And again, I'm going to try to do the same thing I did before. I'm going to try and put 64 in terms of base 5. Well, can I do that? 5 times 5 is 25, and 25 times 5 gives me 125. I skipped right over the 64. I did not get to 25. So obviously, the method that I used on these first two is not going to work for this. So if you recall, we said there was another method that we could use, and that's what's called the log method. We take the log of both sides. We write log 5 to the 2x. We just write the word log right in front of it. It has to be a log on both sides. I just put the word log in front of the 5 to the 2x. I put the word log in front of the 64. Now, the reason I'm doing that is because the rules of logs, the properties of logs tell me when I have an exponent and I'm working with logs, I can make that exponent the coefficient. So this will actually give me 2x log 5 equals log 64. And what I'm going to do is first try and get rid of this log 64. Now remember, this is 2 log. There's nothing in between here, so this means that we're multiplying times log of 5. So let's divide out the log of 5 from both sides. This will give me that 2x is equal to the log of 64 divided by the log of 5. Now, if you notice, I did not do log base 5. I didn't even put a base here. But if you recall what we said on Tuesday, this is not a mistake. When I write the word log and I don't have a base in it, it's understood that it's what we call a common log, and the base is 10, I'm sorry. Log, plain log, this is telling me that the log of base 10 of 64 divided by the log base 10 of 5. And the reason I want to do the log base 10 is because that's on my calculator. I'm going to talk about a second log button on my calculator as well, but this is, if you see on your calculator, you have a button that looks like this. And notice it doesn't have any base written in, simply because it's what we call a common log. It's a log whose base is 10. So if I'm going to do the log of 64 divided by the log of 5, on my calculator, I'm going to press my log button. It'll come up with a word log with a parentheses. I'll put in 64, close that parentheses, and then I'll do divide. And again, I'll press that log button. And then again, it'll come up with a parentheses, and I'll put in my 5 and close the parentheses and press equal. So log, it writes the word log, 64, close the parentheses, divide by log 5, close that parentheses, press equal, and I get a long decimal 2.58405. I'm not going to put any more numbers in because I don't have space. Usually this is what we call an irrational number because it's a non-ending, non-repeating decimal. But usually they'll ask us, let's say they say, find it to 2 decimal places. Then it means round off after 2 decimal places. The number after the second decimal place, it has an 8. The one after that is a 4. So I don't increase it. So my final answer becomes 2.58. So even though we were not able to put both of these numbers in terms of the same base, we were actually, when we're doing logs, we're putting them both in base 10. We're doing common logs as base 10, and we were able to solve the question. Again, this is only something that you could do using your calculator. Okay. So we've learned to do quite a few things with logs. After, I don't know if I'm going to get to it today, I'm going to talk about another log button on your calculator, but I'm only going to do that after I finish all the other work. If we have extra time, we will talk about that. We are now going to go on to how do we solve logarithmic equations. And we've already started that topic. For example, if I gave you an equation that looked like this, log base 5 of x equals -2, you could solve that equation if you put it in exponential form. I'm going to give you a couple minutes to try that. Basic rule, when you have a logarithmic equation or any logarithmic expression in which you have a variable, it's always going to be easier to understand if you can put this equation that's written in log form in exponential form. Okay, in exponential form, what is our base? Well, our base is always a subscript, so it's 5. What is our exponent? Our exponent is the number that's on the other side of the equation, which in this case is -2. So this means 5 to the -2 equals x. It always equals the number that's next to the word log. And in order to find x, all I have to figure out is what 5 to the -2 is. Now, I can either do this using my calculator, or I can do it using my knowledge of exponents. And I'll do it both ways, and I'll show you that you really get the same answer. Remembering that a negative exponent means that you have to take the reciprocal, means this really means 1/5 to the +2, which is really 1/25. In fractional form, your answer would come out to be 1/25. 25. What if you had done this on your calculator? How would you have done this on your calculator? You would have put in your 5. You would have pressed your exponent button. I hope everybody knows now where the exponent button is. And you would put in -2. Remember, when you're putting in the negative, it's the negative button, the minus button, not the subtraction button. And if I do that, 5 exponent -2, and press equal, it gives me 0.04. Now, it looks like these two answers are different. But if you were to take the 1/25 and convert it to a decimal by doing 1 divided by 25 on your calculator, you would also get 0.04. In other words, your calculator gives you, unless you have your calculator set in what we call math print, it will give you your answers in decimals. If you want to compare it with a fractional answer, all you have to do is take the fraction and divide the numerator by the denominator, and you see that your answer is 0.04. So if this was a multiple choice, you'd have to pick the choice that says 1/25. The likelihood is the questions are going to be in fraction form, not in decimal form, but you can take your choices that are in fraction form and convert them each to a decimal and see which one works. All right. Now, what if I were to have given you this equation? Log base 2 of x plus 2 plus log base 2 of x equals 3. And we have a problem here. I know when I have a log equaling a number, I can switch the log from log form to exponential form. But in this case, I have more than one log on a side. What do I do in that case? My rule for switching from log form to exponential form depends on having the word log on one side, and on the other side, a number. You can't have more than one log on a side. So what are we going to do? Well, I can remember from my rules or properties of logs that when I'm adding two logs, I got that when I was actually multiplying numbers. Remember on Tuesday, we wrote this rule: the log of AB is equal to the log of A plus the log of B. Because logs are exponents, when you multiply the numbers, you're adding their exponents. So I could go backwards on this. Since these two logs are being added, it must have meant that originally what I had was the x and the x plus 2 being multiplied. In other words, this is the expanded version. Let's go from the expanded version backwards to the contracted version. Oh, now I have the situation where I have a log on one side and a number on the other side. So I can switch it now to exponential form. My base, I see, is 2. My exponent is 3, because the word log is equal to the 3. The number on the other side is the exponent. this has to be the x plus 2 times the x. And now I don't have any logs anymore. I can just solve this equation. 2 to the third is 8. And x plus 2 times x, I can use a distributive property, will give me x squared plus 2x. And what I have here is a quadratic equation. I'm going to give you a couple of minutes to solve that quadratic equation. Okay. So let's see if we can finish this problem off. We have 8 equals x squared plus 2x. It's a quadratic equation because I see an x squared. And I want to solve the quadratic equation by setting it equal to 0 so I can try and factor. And it's just easier to bring the 8 to the right side than to bring everything else to the left side. So I'm going to subtract 8 from both sides, which will give me 0 equals x squared plus 2x minus 8. And this actually does factor x and x. What multiplies to 8 and subtracts to 2 is 4 and 2. And it's going to have to be a positive 4. The larger number is going to be positive, and a negative 2. So we say each of these equal to 0. So x plus 4 equals to 0. Gives us x equals negative 4. And x minus 2 equals 0. Gives me x equals to 2. So I come up with 2 answers for the value for x. Now I have to look at the answer and see if it makes sense. If you recall, I mentioned on Tuesday, when we first started talking about logs, I talked about the fact that if you take the log of a number, let's say take the log of base 2 of x, and we say it's equal to, even if we say it's -3. And if I have something like this, when I switch it to exponential form, it'll give me 2 to the -3 equals x, which simply means that the x is 1 over 2 to the 3rd, or 1/8. Even though this number was negative, this number, the x, can't ever be negative, because the x is the result you get by putting a number, and remember your bases are always positive, some number to an exponent. You take a positive number and put it to a exponent, whether it's 0 or negative or positive, your answer is always going to be positive. In other words, this is what we use the word domain. The domain of the log always has to be positive numbers. How does that affect you? It means that you have to make sure that when you have an answer that you get for a log problem, that none of the answers come out to be numbers that you'd have to make negative. Let's take the answers that we got over here. We got one answer to be x equals -4, and one answer to be x equals 2. If I try to use the -4, I get log base 2 of -4 plus 2, which is -2, plus log base 2 of -4. And I can't use this. This has to be wrong. I cannot do the log base 2 of -2. Try it on your calculators. Just press your log button and put in any negative number at all. Put in even 0, and you will get an error message. It's not possible to do the log of a negative number. So this is what we call an extraneous root. We had a similar situation when we had sometimes had answers for fractional equations, and they made the denominator equal to 0, so we couldn't use it. The same thing over here. We cannot use an answer that makes us take or do the log of a negative number. On the contrary, with the 2, when I'm trying this answer, I'm getting log base 2 of 2 plus 2 plus log base 2 of 2 equals 3. And this is fine. This is a good answer. I can see because everything is positive. I could even, if you want, we can check it to make sure it makes sense. Log base 2 of 2 plus 2 is 4. Is what exponent? Remember, the log is the exponent. The base is 2. The answer is 4. 2 to what exponent gives me 4? And obviously that answer is 2. This is the log base 2 of 2. 2 to what exponent gives me 2? Obviously, that's 1. 2 to the 1 exponent is going to give me 1. And notice 2 plus 1 does give me 3, so it does indeed check. So here's something we have to be very careful about. When we solve a log equation, if it has multiple logs on one side, then we have to condense it to a single log, contract it back to its individual logs. If there's a plus, it means that you have to multiply. If there's a minus, it means you have to divide. You're going to then get a regular equation, a regular algebraic equation to solve. You solve that equation, but make sure you check whether your answers make sense. Can your answers work? Because you cannot do the log of a negative number. One other thing that might be interesting to note that whenever, this is in case you want to check things, whenever the log, the base matches the number, if you do the log base b of b, your answer is always going to be 1. Why? Because what exponent do I put on b to get b itself? And the exponent has to be 1. So sorry. If I ask you what's log 12 of 12, the two numbers match, the base with the number next to the log, they match, the answer has to be 1. Log of 3 of 3 has to be equal to 1, as long as the numbers match. And log of 10 is also going to be equal to 1, because when I write the log without a base written in, we understand that the base is 10, and again, these two match, the log is 1, because 10 to the 1 will give you 10. So this is something that's very interesting. If you see it, if you see these two numbers being the same, you could just replace that whole expression by 1. Okay, I'm going to give you another example to try. Okay, here's the question. And this is off the final, so I'm going to give it as a multiple choice. It's log base 2 of x plus 7 plus log base 2 of x minus 7 equals 3. And here are your choices of answers. Okay, let's try this together now. Again, like we had before, we have two logs on the left side of the equation, and the sign in between them is a plus. And I know when you're adding logs, you must have originally been multiplying the numbers. If this would have been a minus, I would have been dividing them, but this is a plus, so we're multiplying this. So I could write this as a single log. I can contract this back to a single log by saying log base 2. The first number, of course, goes on top. It's this. I'm sorry, we're multiplying, we're not dividing. this is going to be, since this is a plus, we're going to be multiplying x plus 7 times x minus 7. And that's going to give me the 3. Okay, so now that I have just one log on this side, I can change it to exponential form. So my base is going to be 2. My exponent is going to be the number on the other side, which is 3. And that's going to give me x plus 7 times x minus 7. And I know what 2 to the third is. 2 to the third is 2 times 2 times 2. That's simply 8. And I can also multiply the x plus 7 times the x minus 7. I can remove the parentheses. These happens to be conjugate binomials. So I don't have to do the whole FOIL. I could just do first and last. So x times x will give me x squared. And 7 times 7, that's minus 49. And I'm going to bring the 49 to the other side. So that it gives me 8 and 49 is 57. I get 57 equals x squared. Now this is again, a quadratic equation, but a really simple one where we can solve it using what we call the square root principle. Since x squared equals 57, I'm going to put the x first. The x could either be plus or minus the square root of 57. Remember, that was our rule. If we have x squared equals a number, then it's my answer either positive, the positive square root or the negative square root. But remember here that we're dealing, my x has to be able to go into a log equation. And the square, if I can use the positive square of 57, that's fine. But the negative one won't work because then I'll be taking square roots of negative numbers. So in this case, I eliminate the negative square root and just give the answer positive square root of 57. And actually that happens to be choice number A. So it's a matter of compressing or contracting your equation back to a single log, changing it from the log format to the exponential format, and then solving the equation. Now let's do one more like this. So let's see if I put this problem on the board, if you can do this one. Suppose I gave you this equation. Log base 3 of x plus 2 minus log base 3 of x equals 1. I'm going to give you a few minutes to try and solve that logarithm equation. Okay, again, we have this situation where we have log on one side, number on the other side. We'd like to switch from the log format to the exponential, but there's more than one log on a side. And the sign between the two logs is a minus, not a plus. Before we were doing a plus, we knew when it was a plus, we had to multiply. Remember, the rule is that when you have A divided by B, remember the logs are your exponents. When you're dividing, you're subtracting the logs. So if I want to contract this back to a single log, I've got to write this as log base 3 of the x plus 2 divided by the x. The minus here meant that I was dividing. And now I can just since I have a single log, go to the exponential form. My base is 3. My exponent is a number on the other side, which is 1. That's going to equal the thing that's right next to the word log, which is the x plus 2 over the x. Now the 3 to the 1 is just 3. Now I'm going to write this as 3 over 1 because this side is a fraction. I'll write this as a fraction. And I have a proportion that I can just cross multiply. 3 times x will equal 1 times x plus 2. And that's just a regular algebraic equation. I'll subtract x from both sides. That'll give me 2x equals 2. So that x equals 1. And I just check. 1 plus 2 is 3. That's positive. 1 is positive. This is a good answer because it doesn't make anything negative. If this would have been a negative number, if it would have worked out to be a negative number, then I would have just said no solution. In the other cases, we got 2 answers. One worked, one didn't. The situation is totally dependent on whether the number you're taking the log of is positive or negative. Don't automatically say, oh, I have 2 answers, I have to get rid of one of them. Sometimes both answers work, sometimes neither answer works, and sometimes one works and one doesn't. In this case, we got only one answer and it just happened to work. It could have been that the one answer we got didn't work either. So always keep in mind that you've got to check the final results to make sure you're not doing the log of a negative number. Okay, I just want to speak a couple of minutes about the other log example. We basically completed the work for the term. I'm going to speak a few minutes about the other log button that you may see on your calculator. Give it a little bit of an explanation, just because it's a very important button, especially when you go into calculus. Those of you who are going into further math, you're going to be going into calculus, pre-calculus, and then calculus. And this other type of log that we haven't talked about yet is something that is going to be very important. So I just want to give you a little introduction on that. Again, what you have to know basically is how to change from log to exponential, from exponential to log. Understand what that means. We talked about the button on the calculator that said LOG. And we said that that stands for log when our base is 10. And actually, when we have log base 10, usually we'll just write the word log. Anytime you see the word log written without any subscript, it means that the base being used is 10. It's what's called a common log. And that's basically, you're going to see, I'm sure you'll see on the final, certainly on the practice final, I saw that there were some equations, they didn't write, they had an equation that might have looked like this, except there was no base written in. You have to understand if no base is written in, the base is 10. Okay, now on your calculator, usually right below the button that says log is a button that says LN. Now LN is also a log button. The base of this log is a special number called E. E is what is called the natural number. I don't know what's natural about it because it's a very strange number. It's equal to 2.718. It keeps going on and on and on. It's an irrational number, sort of like pi. We use the symbol pi because pi is a non-ending, non-repeating decimal. The same thing is we use the letter E to represent this special number 2.81718. It keeps going on. I don't even remember what it goes on to. It's built into your calculator. It happens to be a very important number in various calculations. There's what we call exponential growth questions, where they can only be answered using this special number E. If we use E as a base of our logarithm, then we get the special, something called the natural log. The natural log is ln, and what ln means is really log where you're using as your base the special number E. The only thing they really have to, you might be asked to find is, what if I asked you, what is ln E? And if you think about it, ln E would be, remember we said ln means log base E, and log base E of E, remember what I just told you, when the base matches the number you're trying to find the log at, the answer has to be log equal to 1. So ln E is equal to 1. That's important information. Again, I don't think you have to know anything more about this than it's going to come up and you're going to see it. But all the things that we talked about with logs work with this ln as well. In other words, if I had said this was ln x plus 2 minus ln x equals 1, again, I do the same thing. I do ln of x plus 2 over x equals 1. It just, all the rules that apply to logarithms apply to this ln. Just remember, ln is just another way of writing log base E. Okay, I think from there we're going to end. I'm going to just remind you that I have on your final exam is going to be on a week from tomorrow, on Friday, December 11th, from 9 a.m. to 11 a.m. And please set aside that time. Make sure you're on time. Obviously, I'm going to set up the computer so that there's a little bit of leeway. You'll probably be able to start a few minutes before 9. If you get here, in other words, I may set it up so it goes from 8:45 to 11:15, just to give you leeway. But once you start the test, you're going to take the test on Blackboard, just like we did with the midterm. It's going to be on Blackboard, and once you begin that test, it will automatically, once you stop it, it automatically submits. So you can't do start and stop. Once you start it, you have to complete the whole test. I will be available at these times if you have any problem with your computer, so that if I have to reset something for you because your computer froze, and those things do occasionally happen. They don't happen so often, but occasionally they do. I want to be available to, so that's why you need to be there between 9 and 11. What else did I want to say? If you are entitled to extra time, I know I have the paperwork, but please send me an email just reminding me that you have gotten permission to have extra time. If you're a DA, then you can, if you have gotten it and you've never sent me a notification, make sure that I get the proper notification so I can give you the time that you are entitled to. I have posted on Blackboard a practice final. What I will do is, if you do better on the practice final than you've done on some of the other tests, I will exchange the mark that you get on the practice final with the mark that you got on one of the quizzes, so that your average will be higher. Remember, at this time, by Saturday, this Saturday, the 5th of December in the evening, I want all homework, all tests, everything completed. The only thing that you can have extra time doing is this practice test, because I just posted it. But all the homeworks and everything, I think there are a total of 17 homeworks. I will give complete credit for homework, which is 10% of your mark, if you have completed at least 15 of the homeworks. If you left out 1 or 2 homeworks, I will still give you complete credit for the homework if you've done at least 15 of the homeworks. I will, so there's going to be 10% of your mark is going to be the homeworks. There's a 10% that's on your midterm. If you haven't taken your midterm yet, and there are 1 or 2 people who haven't, make sure you get in touch with me so I can set it up so that you can still take it, because the midterm itself is 10% of the mark. And 20% of the mark are the tests from Delta Math and the Blackboard tests, not including the midterm, but all the other tests. There were 3 tests on Delta Math. There were, I think, 2 tests on Blackboard, remembering the practice midterm was considered a test. And also, I just gave you the test on conics and trigonometry. That was also on Blackboard. I gave you a practice quiz. That was just homework. That's not a test mark. It's just to make sure you know how to do it before you take the actual test. So make sure you've got the 3 tests in Delta Math done, the practice midterm, and the test on conics and trigonometry on Blackboard done. For that gives you 20% of your grade. So there are 5 marks that will be averaged out, and that'll be 20% of your grade. Remember, the final exam itself is 60% of the grade. If anybody has any questions, I'll stay around a few more minutes. Otherwise, I will see you on Tuesday. Our last class is this coming Tuesday, and we will be doing what I'm going to do. I hope a bunch of you will try those practice finals, and I'll look them over and see what topics people are having problems with, and I'll review those topics. If you have a topic that you'd like me to go over, you can also request that either in a chat or in an email or in person. Okay, have a nice weekend. As I said, I'm not ending this now. You can leave, but I'm not ending it for if anybody wants to speak with me.
Okay, thank you. Bye, Professor.
Bye-bye.